rely on Rid giving you a nice API that guarantees memory safety. So you don't have to worry about that yourself. What we're going to do is we're going to build this app over here, which is a simple to-do app, but it has a twist. And you're already starting to see some logs coming up over here. But basically, this one has a twist that if I turn on to expire completed to-dos, it will expire those to-dos, right? And it will give you a progress bar, and when they expired, then they actually will be removed. That's the main twist that we have here. So what we just looked at, I'm going to walk through how that actually works, like what's actually going on under the hood. How do you communicate with from a Flutter to Rust? And we will also look at how we can then orchestrate that with cubits. But first I'm going to just walk through what's going on here. And I have a little Miro. No, I don't want that right now. I have a little Miro prepared, Miro board that kind of helps us to understand a little bit what's going on. So actually I'm going to turn off for a second the expire completed thing. And so this basically goes from left down here back to here, right? And what we see here in the middle, this is like the part that's implemented in Rust. And it looks fairly complex, but we'll walk through it piece by piece and you'll see it's not going to be that difficult to understand. Let me try to zoom into here. Okay. So at first your Flutter app starts up, right? And then it wants to show first of the to-dos that are there. So it says I want to get the to-dos. And there's going to be a to-dos Cubit. And notice here that there's a list of to-dos. And this list is actually a Dart list. And these to-dos are actually Dart instances. So the to-dos Cubit does not really operate directly on, let's say, pointers or anything coming directly from Rust. It operates on things that have already been converted to Dart objects. And we're going to talk about that in more detail later, but that's basically part of that really nice and easy to use API that Rid now provides. And now what does it do? It will go to the store and say, hey, give me all the to-dos that match the current filter. Currently the filter is to show all of them, right? So it goes there. And now what's happening here, the store actually will say, okay, I'm going to get you the filter to-dos, but I'm also going to make sure that I'm going to lock, right? The store will be locked, so no one can write to the store until the filter to-dos have been retrieved and have been fully converted into a Dart list. So you don't run the risk of accessing anything that is being mutated or that might no longer be valid and so on. So let's actually look at that. I'm going to clear here a little bit, and let me get this back. And now if I click here, we're going to see what's happening. So I'm going to click on that, and you can see that I clicked on it. I got a posted reply, right? So basically my message to get the okay, so actually I already went ahead of myself here. I clicked on this now, right? So this is where we are. We have the to-dos. I clicked on this now, and so what's happening? So here we are sending a message that we want to toggle it to do, right? So basically we don't want to do any mutation directly, right? We want to basically just talk to our Rust code with messages, right? It's not really that messages are being sent over the network or anything, but it's still function calls, but they are modeled as messages, right? So the store now gets a write log on itself so it can update itself, right? And why is that? Well, in Rust, Rust itself provides safety for kind of multi-thread applications to make sure that we can't mutate things that we might be accessing on other threads and so on. But once we basically leave Rust and re-enter Rust from Flutter, and then that safety is kind of removed, and we have to reintroduce that. And that's why we're basically saying that, okay, you want to update the store, you need to get a write log on the store so no one else can get a read log at the same time, right? And no one can read from the store while that's going on. So the store gets updated, and then the store posts a reply to us, and that's what we see down here on the right, that, okay, I toggled the to-do that you wanted to toggle, right? And so now the to-do Cubit gets activated because the to-do Cubit was being basically used to also initiate the message, and it was basically awaiting for that reply. So Rid now no longer assumes that anything is happening synchronously. It assumes that anything could happen asynchronously, and there's kind of a request response kind of pattern going on, right? It waits for the response to that message. So now once it gets a response, it goes back to the store and says, okay, I want to see what my to-do looks like now, right? It got toggled. Most likely, you know, the completed one will just be set to true, but we don't want to have any logic in Flutter. We want to have that all from Rust. So we go back here, and now we get the updated state, and we render it, and now we render checkmark here because it's completed. Now, while this is going on here, the store is actually locked. We can see that here. So we log the store, then we get the to-do by ID, and then we can unlock the store again. But at that point, before we unlock, we already have a to-do, right? We already have a fully instantiated Dart object that's a to-do. We're going to look into that in more detail, right? So it's all memory safe. So you don't have to worry about these things because they happen under the hood. Now we're going to get to something interesting. So what if I want to auto expire to-dos, right? So if I turn that on, right? So what happens here? Well, if I click that, then I'm changing settings, right? So this drawer over here is managed by the settings qubit, right? Now, the settings qubit will send a message and say, I want to toggle auto expire. And at that point, the store will say, okay, I'm going to get a write log like we said before. I'm going to update the store, and it activates a ticker thread, and we're going to look at that in a second. Now, what it then does, it posts a reply that that expiry is now turned on, and what will then happen, and we'll see that, is that the settings qubit will change its state because now the settings changed, right? It will obviously have to get these settings from the store again. We don't show that here, but eventually the to-do view that is watching the settings provider, right, now knows that it needs to show a progress bar down here, and it does that, right? Now, let's do that real quick, and I'm going to try to do this quickly enough to where we're not getting too many messages. So you can see that we started auto expiring and we stopped auto expiring. That all happened very quickly, but basically you can still see what happens. So we got a set auto expiry completed to-dos. We got the request, and now we can also see that the settings qubit now asked for the updated settings, and then the to-do asked for its updated state and so on. So all that worked as we would expect, right? So let me reset that to-do. Now, what's going on though at the same time is when we actually did activate this, and I'm going to actually let this run a little bit so we can see that. So while this is being activated, something has to basically tick the to-do, and I'm going to uncheck it so it doesn't disappear. Something has to basically tick this, right? Something has to tell us that how much of the to-do has been expired, of the remaining lifetime. So that is handled on a different thread in Rust. This is handled on the expiry ticker thread, right? So the expiry ticker thread is just basically every so many milliseconds or so, it will basically look through all the to-dos that and find all the ones that are marked as completed, and it will basically remove time from the from their life that they have left, basically, and then it will post a reply. And in this case, this goes through the replyChannel stream. And the replyChannel stream is something that exposes all events to us. When we actually send a message and await the result, this also is handled via the replyChannel stream, but it's kind of hidden from us to make it easier. So we can basically await the future of our message being resolved, right, with the reply. Now here, the to-do qubit actually directly listens to the stream of to-do ticks, right? So every time Rust now tells us that there has been a tick, this to-do qubit will say, okay, let me actually go back and see what's the state of my to-do now. It will go to the store, and it will get back a result, and now it can basically update the progress bar like we saw here. Now, life goes on, and we get another tick, right? Now, again, the to-do will go to the store, get the updated to-do. Now, while we're actually getting the updated to-do, first of all, before we can actually get anything, we have to acquire a read log, right? So if the ticker thread was writing at the same time, right, as we are coming here, we actually would have to wait for that write to complete before we can read now the latest state. So there's no race condition going on. Like we get a read log only once the expiry ticker thread has given up the write log, right? And while we are holding the read log, the expiry ticker thread cannot acquire a write log. It actually has to wait till we have fully resolved our state, and we then instantiated a dart object from that, and then we can basically update our state over here, right? So that's the memory safety that we give. And actually in the next example here, we want to show why that's important. So now we actually get another tick, but at that moment the to-do actually expired, right? The to-do expired, and we basically still go and try to get the update to. We got a tick, right? So we want to get our state. Well, at the same time when it expired, the ticker thread realized that, and it said, oh, we need to remove that to-do, and it actually goes and removes it, right? And it still has a write log on the store, so it can actually go ahead and remove it. And then it posts a reply to let us know that this to-do expired and has been removed. Well, if we were to, for instance, hold on to like a pointer of this to-do here, and then say, give me the title of this to-do, well, what would happen is the pointer, once it got removed over here, would now be invalid, right? Like this is really tricky stuff that you have to watch out for, but with Rid, you don't have to watch out for that, because Rid basically handles that for you under the hood. You don't get to work with pointers, right? You can, there's a more low-level API that you can use if you need like that, but that's only for special cases. But in general, you don't have to care about this. So what happens now, we go here, but the store now finishes writing, right? And the to-do has now been removed. And now we can actually run this code, and we try to get the to-do by ID, but the to-do is no longer there. So we get nothing back, right? And then our view actually knows how to handle that, because the to-do is missing. So we can either render that like this, or we can say the to-do is no longer there, or we can just not render it at all. It depends on how we want to handle that case. But at the same time, the reply channel now will also send a to-do expired, right? Because the expiry thread posted that. And now the TodosCubit that is actually listening to those events will see, oh, some to-do expired. I need to go and get the updated state of the list of to-dos, right? Of the filter to-dos. It gets that, and now basically this to-do has disappeared, and it renders that in such a way, right? And we're going to show that real quick again. So this is still turned on, and if I now run this, you can see it's expiring, and at some point it gets just removed automatically. Now, right, we could have other race conditions where it's expiring, it's almost about to be removed, and I unclick it, right? So there has to be certain protections. If I do that like right here, we have to make sure that there's no race condition. Also, if I remove it, right, now we have to make sure that no one else is trying to work on the to-do while we remove it. And that's all guaranteed because of those read and write logs. And over here, we can see every time we try to get something here, we log the store, right? This is kind of what Rid logs out for us to help us to understand what's going on. And that is pretty much the introduction to the application that we're going to build. Right? Now, I don't think we will be able to build all the features that this application has in this stream, because I don't want to take too much time to show this. But what we'll focus on instead is we'll focus on how to basically build those qubits, right? To instrument the interaction with the Rust application that we built, and we will also focus obviously on the multi-threadedness and how that all works. And we built the expiry ticker and all these things, right? So that's pretty much all I have to wanted to show for now before we start building this. So the project that we're building is this. We're building this app with the extra twist that to-dos expire, so you can kind of look there. The code that we're actually of the fully implemented app is here, right? And I think I put that on Rid, and the framework that we're using to interact with Rust and so on is here, right? So if you're interested, you can jump here. Now the other thing is that Rid itself is not yet open source, because I'm releasing it as sponsorware to be able to get enough sponsors so I can actually keep maintaining Rid. I don't want to just release it and open source it and then not have the resources myself or the bandwidth to actually go in and maintain it. I want to be able to basically dedicate enough time, and that's why I need sponsors. If I get to 60 sponsors, I'm about 20% there, I will release Rid open source. But and I go into more detail in the previous screencast about this, so I don't want to go into detail too much now. But if you have any questions so far, feel free to ask questions here. Okay, now we are pretty much done with showing this. So I'm going to make it smaller. And what we're going to do now, we're going to close this app, and we're going to jump to our starting point. So what we have here is the starting app, which Rid gives you once you initialize. So when you say, I want to create a new Flutter app, what it gives you is, well, you guessed it, it gives you a counter, right? Everything in Flutter starts with a counter app. So this counter app is kind of demonstrating how things work as well. So we can, for instance, say we increased, right? We get a reply that we increased something. We can also see that the store gets actually printed here, right? And we're going to look into how that works in a second. And then we can see that the app actually asked for the updated store count and made sure to lock the store to do that. The only little twist here is that we can add 10 as well, but we can keep adding however we want, and we can see how these replies coming in and so on. So let's actually look at that code before we will remove it entirely, because we will not use it. But it actually can serve to explain the concepts here a little bit. So what we have here is we have a Rid store, right? And in this case, the store is basically the entry point to our app. It holds all the state, and it also allows us to modify the state, right, via messages. In this case, all our state is just a count, right? How much did we count? And then here we implement the Rid store for it. And that basically just requires us to implement two methods, right? In Rust, we basically create the store, right? Somehow we have to give the initial store. And then we have another method here that allows us to update the store, right? And we see that we get ourselves passed in here as immutable. And Rid, before calling the update method, basically acquires a write log to the store to make that happen, right? So we can be sure that we can, once we are here in this update method, we can mutate the store without having to worry. Now, the other thing here is the request ID, and that's basically attached to every message, a request ID, and that we then use when we reply with that request ID, so Rid knows, oh, this reply was for this message, right? So that basically makes it possible to await basically the result of messages, or at least the completion of messages, right? And then here we get the message. And right now we have two kind of messages. Either we just want to ink, or we want to add a certain number, and in that case we added 10. And so we then reply. So here we have the message implementation, and here we have the reply implementation. Now the message needs to know what the type of reply is, just to generate the correct code. And at the same time, the store actually has to be called store. That's a convention that makes it possible for Rid to generate a bunch of code in different places, assuming what we call the store. And so we don't have to provide that name all over the place. That is the idea. So I hope that's pretty clear. I'm going to look real quick. I'm going to show real quick how that's being used. So here, for instance, we get the store. We just try to get the instance, and that basically then has the store created, right? And if we want to interact with the store, for instance, we can just say, give me the store count, right? And now if you go here, you're going to realize that this basically is a higher level method here, and which actually makes sure that the store is locked with this thing here. The read method actually locks the store while our code is running until we get back a fully instantiated Dart object. In this case, it's just an int, so there's not much going on, but that's how that works. All right, so let's actually delete all this, and we're going to start all from scratch with our app. Right, and since I already did this on the other screen over here, I have some of the code just to make sure I don't make any mistakes. So first, what we need, obviously, is we need and actually let me close this for now. Oh yeah, let's close it. First of all, we need a to-do, right? So we can say we create a struct to-do, right? And so what does a to-do actually have? Well, a to-do has an ID, right? So you can look it up. and a to-do also has a title. A to-do also has a completed flag, right? And then the other thing is it has expiry millis, and that's basically telling us how many milliseconds are left until this to-do, if it's completed, will expire, right? So now we got our to-do defined. Well, here Rust is complaining we are not using this. Yes, that's because we have to first say it's a model, right? So now we told Rid this is a model, and we can't make it private, so we have to make it public, and now everything is happy again, right? So, but we don't have a store yet, right? So let's actually implement a store. So how we do that? Well, first of all, it's another struct, right? Struct store. And in that store, we're going to have the last added ID to keep track of basically what kind of IDs can we give our to-dos, right? And then have to-dos, which is a vec of to-do. And then we have a filter, which we are not worrying about yet, and we have settings, which we also don't worry about yet. So I'm not going to put that here yet. Now again, in this case, we have a special kind of model, which is called the store. That's kind of a model that is the store. Now we see here that this is complaining about this to-do because it does not know what this to-do is. Now you could say, well, why does it know? We tell it down here that it's a to-do. It's just a struct, right? It should be able to read that. Well, these attributes, when you do like these proc macros, they're called in Rust, they don't know about each other. So we cannot assume that this can find out that this is a to-do. So we have to tell it right here and there. That's how that works. So we have to basically say, I'm going to tell you what all the structs are. And so once I put that here, it knows that to-do is a struct and it's happy. The only thing that it's not happy about is that there is no create method found on the store, right? That's because we haven't implemented yet. So it's kind of telling us what we need to do. So what we need to do is we need to actually implement Rid store, right, for the store. And then we can just use our generation here. And so I'm going to copy that code in a second from over there because we're going to actually have some initial to-dos. I'm not going to implement that by hand and bore everyone. Here's another problem that we have. We have something called tMessage. And what's tMessage? Well, we actually were supposed to put that here. We're supposed to put here that this is a store that takes this kind of a message. But we don't have that yet. Right, so the message is not implemented. So let's rectify that. Let's implement a message, and all the message types we need for now is basically, and let's keep this in order. So we're gonna put to do here. We're gonna put store. So because this is gonna grow a little large with lots of pieces, and so we're gonna try to make our life a little easier. This is a message. Okay, so the message is in enum, right? And in Rust, basically, you can have enums that can hold data. So in this case, for instance, we have toggle to do is our message. We want to toggle it to complete it or not complete it. And we have to give it the idea of the to-do we want to toggle. And that's basically where we use the feature in Rust that we can pass basically data with our enum. And then what we also need is a reply to that message. So then we can say toggled to do. Now, the first parameter is always a U64 if a reply is for a message, because that will contain the request ID or the message ID that the reply is for. Now, the other thing we're going to include here is we're going to include a string. So we can include one kind of data in a reply, which is just a string, and we can put anything in there. In this case, we'll put in there what the idea of the to-do was that we actually completed or toggled. So other tools that don't even know about the message, but they only see the replies, can actually identify which to-do the reply is for. Okay, now we can hook this all up. You can just say Rid, this is reply. And then here we can say Rid, this is a message. And the reply that you're going to get is of this type. All right. So, and let me put header here, reply. So we got now the store, we got the message, and we got the reply. And for some of you, this may sound familiar. And it is. This architecture is very Elm-like, or some of you might know about Redux. It's somewhat similar to that. And it's the only difference here is that we have all kind of asynchronous things that are easy to do. Now, what I'm going to do is to create the store. So I'm going to copy some of this code, because I don't want to write this all by hand. So we have 4 to-dos, right? We have 4 to-dos, and initialize them like this, and then we're basically going to initialize our store. So the store basically will just have all these to-dos, and it will say that the last added ID was 3, right? Because because we just added 3 here. Now, I don't know why it's complaining. No such field store. Oh, okay. So let's see. Oh, to-do. We need to have to-dos. The other problem that we have, we're missing this constant. So let's just put that here. This basically just tells us this is the overall time that to-do, once it's completed, will take to expire, 7 seconds. And obviously, like when we start them out, they haven't expired yet, so they are 7. So at this point, we got the creation done. Now we just need to basically make update work. So how do we do this? Well, what we're going to do, we're going to match on the message that we're getting, right? And then we can just fill out the match arms. And in this case, we want to toggle it to do. And now we need to implement the code here that will actually toggle it, right? Okay. So again, so what we're going to do, we're going to have a bunch of methods that operate on a to-do. So first of all, it needs to find the to-do, and then it needs to operate on a to-do. So what we're actually going to do, we're going to, and no pun intended there, we are going to implement as a helper method that is called update to do that basically does that. So we can use it in different cases, right? So what we're going to do, we're going to implement some method on the store, and it's going to be called update. And so what this does, it finds a to-do, right? And it finds it mutable because it wants to then do a mutable operation on it, right? The update method itself needs a mutable to-do, so that's why it gets mutable to-dos. Finds the one that we want to work on. If it can't find it, it will print a message, and basically we'll pass the we call this on the mutable store, right? Now it tells us that we are not using this yet. Well, we can fix that. So basically what I'm going to say, hey, look, we are going to export something in this impl, and by the way, we need to tell it again what the structs are. As I said, they don't know about each other, and then we just say, and this is a method we want to export. Okay, so I'm not sure why it's complaining now. No, that's not. That shouldn't be an error anymore. Let me see. Oh, the thing is, okay. This one actually we don't export. And that's why I got confused. We don't have to export this, right? Because we only call this from inside here, right? We don't call this directly from Dart, so we don't have to export it. We only have to export things we want to call outside of Dart, from Dart. Now, what we do is we're going to say update to do, right? Self.update to do, and we're going to give it the to do ID, which we have here, and then we're going to well, it's got the wrong name, that's why it's all confused. And then we're going to say that we're going to find we get the to do here, right? And let me actually make sure that I get that right. Okay, so we're gonna get the to do here. I got that right actually, and we're gonna then say that the to do completed is the opposite of what it's now, right? So that's how you toggle. So and we don't want to do this, because what we also have to do once we are done, in order for Rid to know we are done, we have to actually post a reply. And so we're gonna post a reply, and we toggle the to do, and we're gonna give it the request ID, and then we're gonna give it the to do ID.toString, and then we're done. At least I think so. We might be missing a little something. Let's see. It should be fine. I think I might be missing a parentheses here. Yeah. Okay, so now we got that all set up. So now basically we can toggle it to do, right? Okay, but we can't get the to do's yet, right? So we're missing that. So But what I wanted to do, I wanted to implement a bunch of Rust so we don't have to restart, because every time you actually change something in Rust, you have to restart the entire app. You can't do a hot reload or hot restart because this library has to be loaded in. So let's actually now implement something where we can actually get the to-dos. That's actually what we would want, right? So what we need to do is get the filtered to-dos, right? And for now, we have no filter. So so what we're going to do, we're just going to return all of them because we're just going to assume that there's no filter, right? Now, the filter to-dos actually just has to take a reference to the store and not a mutable reference, because it's not going to mutate the store at all. And what it's going to do, we're just going to take the to-dos, we're going to iterate over them, and then we just collect. Right, and then and that's just to get a. In the future, obviously, we will filter them according to the filter. Right. Now, what that returns us is a vector of reference to-dos, because we're not cloning the to-dos, we're just returning it. Now, what's going on? Okay, let's see. Oh, because we have to actually put it here, not here. So that's what that is. So now we have the filter to-dos, but they're not being used. And now we actually get to export something. Remember that all the stuff I had before, we actually need that now. And again, we need to tell it that the to-do is a struct, right? Because it can't know that by itself. And so then we can also put just an export here, right? And then it's all happy. And now this method will be exported. Okay, so now I think we got us to a point where we can create the store, we can get to-dos, and we can also toggle one. So I think we are ready to go ahead and get to the Rust Dart part. So first of all, what we're going to do, we're going to bind gen. And bind gen, what that does, it basically takes our app, and Rid will basically expand, like all these macros that we have there, will basically expand, and it will generate Rust methods, right? And these Rust methods will then be used also to generate Dart methods that kind of call these Rust methods. So all this API is basically being generated, and now it's done. All this, and it won't build every time. It will actually be, the second time will be much faster. We'll see. So it's like that fast. Obviously, also what we need to do, we need to build the. We're going to run this with macOS. We also need to build this. So let's just make sure we did that. Right, do it twice just to be sure. So now if you run this, nothing will work anymore, because our main Dart still has all this other stuff in it which we don't use, like the counter app. So we're actually gonna remove that. So what we're going to do here is we're going to start small. We're going to just basically try to render the to-dos in some fashion first, and we're not even going to worry about appearances, right? But before we actually do that, what we need is we need a way to get that state, right? And as I said, we're going to use Cubit, which is, in my opinion, a much easier to use version of Bloc. It is much less verbose, and it works especially in our case. And in case some of you are wondering, I also tried RiverPod. And RiverPod is nice, but it does a lot of things that are actually overlapping with what Rid already does. And once you basically watch for one provider and another provider, things start getting really, in my opinion, a little bit hard to understand and reason about. And Rid pretty much with the stream reply channel already gives you all the stuff that you need. So it's not really a good fit for Rid. Bloc and Cubit is a much better fit. So that's why I went with that. Now what we're going to do is we're going to create a block, and we're going to start with we're going to create a Cubit actually, and we start with just the to-do, right? So we're going to call it to-do, and we're going to create it inside blocks. Okay, and now here we have our to-do Cubit, now to-do state, and so that's what we're going to go with first. Let's do that. So the to-do state. It's actually interesting, right? So the to-do state is here. Now it will always have an ID. So let's actually think about that, right? So we'll always have a to-do ID, right? So we'll do that, and we implement a constructor for that. So that's the abstract class. We always require to have at least an ID. If you don't have the to-do, that's fine. But in order to find it or print something about it, we need at least that. So the other thing is that we can have an existing to-do. That means that actually when we retrieved that to-do from the store actually found it and gave us back that to-do, right? So, and the thing is that will actually have a to-do, right? Because as I said, found it. Okay, now, what's this to-do? Okay, well, first of all, in order for that to work, I'm going to show you real quick what actually was generated. So this is what Rid generated as an API, right? All this code on top of what actually FFIGen generates. And again, if you're interested in that, there's another video I have about Rid, an earlier one, where I go more into detail about FFIGen and all these things. But all we have to know here is that API was generated for us and it has a to-do class in it, right? And so now we imported that, right? And I'm just going to show you what this is. Oh, it's a Dart class. That's pretty awesome, right? So it's a Dart class, actually. You're not even dealing with Rust here anymore. And it has all these properties on the to-do. And not only that, but it also already implements an equals override and a hash code override for us. And it also implements a toString. So since we have all this information on the Rust side of the types, right, we can do that. So very convenient to use, right? So, okay, so we got our existing to-do, and now obviously we need to create the constructor, and we need to call the super in there. And since we have a to-do, we can get its ID. Okay, so ready, right? Now we still, and I'm going to copy that, we still need to implement the equals, because it will not know by itself that it actually has to go and check for the to-do hash code, for instance, and check for, just compare the to-dos that are inside here. So we still have to implement some wrappers, okay? So that's for the existing to-do. Now the other one, and I'm going to just copy that because that's pretty trivial, it's really, really similar, the missing to-do. Well, in case of a missing to-do, we don't even have a to-do anymore. We just have the ID, like, okay, we have this ID, but we can't find the to-do. And we override the equals operator and the hash code as well, and it's just in this case the ID. Okay, so now we got our to-do state for the to-do Cubit, and let's go there. And now what we're going to do is we're just going to implement one method in this case, and that's going to be Todo Completed. But the thing is, we're not even going to worry about this yet because we don't want to get ahead of ourselves too much. What we're going to do first is we're going to do to-do state, right? So we're going to have to, actually we're going to have an existing, when we get started, actually what we're going to get is someone will actually pass us a to-do, right? There's no reason to have a to-do Cubit if you don't have a to-do in the first place, right? So we get that. And then we can basically create an existing to-do with that to-do inside of it, right? Now I think we need to, so why is this complaining? I think I'm missing some import. Oh, okay, what I'm missing actually is the block packages, right, to install them. So let me do that real quick. So there are two packages that we need. And those are Bloc and Flutter Block. So I'm just going to put those here. And actually, to make things look nice, we're also going to have the assets here, just to have the little Flutter dash and the Rust Ferris there. And in order for that to work, I don't want to copy the assets all over the place. So I'm actually have the examples here, and I'm just going to do link it to the assets here, and so that way we don't have to do anything, it just will work. Okay, now it should actually go away here. Yeah, now it's happy. We ran flutter pub get. If we go now back to our previous file, it is now happy. We have a to-do Cubit. All right, success, right? And as you can see, it's the to-do Cubit doesn't have to deal with a lower level API. It just deals with with to-do classes, right? With Dart classes. Now, what we need now is a to-dos Cubit. So let me run this command again. And that will be the block new Cubit, and it will be to-dos. And please put it inside blocks. And now we should have that here. Okay, so let's worry about the to-do state first. The to-do state is actually fairly simple. So we don't even have an abstract class in that case because there's only one. And we're going to call it to-do state. It's still going to be immutable. And what we're going to well, extends, we're not going to extend anything. We're just going to have one because there's no way, like either we have to-dos or we don't. Like there's no to-dos, the list of to-dos can never disappear. It's either could be empty, but it can never just not be there, right? So what we're going to have here is list to-do. Again, it's all Dart, right? We're not worrying about Rust at this point, and we call those to-dos. Let's do that. And then we're also going to constructor. Now I'm going to copy and paste again these overrides. In this case, basically, if the lists are identical, then it's the same. Otherwise, if the list changed, or like in this case, we'll have a new list, a different kind of list, then it will be not equal, right? So that's what we want. And now the interesting part is actually to do the to-dos Cubit. So in here, we need to start it out with to-dos, right? Okay, so what would be the initial one? Well, it would be a to-do state, right? And that one takes, as we know, it takes to-dos. How do we get to to-dos? Well, what we can do, we can go to the store, to the instance, and just ask it. We could get all the to-dos, but we don't want that. We actually want the filter to-dos, right? Because later on we'll implement filtering. Now, interestingly enough, right, we called this actually filtered, under the lower line there, like this in Rust. But the higher level API basically makes it Dart friendly and gives us this kind of method name. And again, here we can see that what's happening is when we call this under the hood, it actually goes, locks a store, right? Then it goes to Dart. It gets a pointer basically to these filter to-dos on the store while it's read logged. And then it goes through all the items, the to-do items, pointer by pointer, and converts them to Dart classes and then gives us a list back. So it's very, very convenient. And you can use that lower level API, but I wouldn't recommend it, right? Unless you have a good reason. So now we have the initial to-dos, and actually that's all we need, right? Because let's just see if we can show to-dos, right? That's all we need for now. Okay, cool. So we are making good headway here. And again, I'm going to copy and paste some stuff because some of this is not that important to explain in all the detail. And I want to make sure I can cover all of this, what I wanted to cover today. So let's just start with this. I'm just going to start importing, and so we want material most likely, and we want this one. And so here what we're doing is we're just saying how should Rid debug replies in Dart. And normally it does this with print because, debug print is only there in Flutter. But we want to use debug print, so we just overwrite that method. And now obviously here we're now starting the app, and this is like a typical stateless widget. And we just actually this one we're going to copy in, and I'm going to walk through this piece by piece. So first of all, here, this is an important part. And as you can see, we don't have a settings qubit and we don't have a filter qubit, but you can also see that we will have it. So it actually makes sense to already start using a multi-block provider, right? And so we have to import that guy. All right. And so what we're doing here, basically, we're creating our material app. We are setting a title, theme, and all the things. And then we basically wrapping our to-dos page with these providers so we can access them, these qubit that we implemented, and then we basically have a to-dos page, and that's pretty much all we want. We disable debug better because it covers the failures of Rust. We don't want that. So the next thing is we have the to-dos page with the stateful widget. The only reason why it needs to be a stateful widget is because we'll later on add a text field there in a dialog to add to-dos, right? And you have to give it the title, and that's why we need a stateful widget there. Okay, now let's do this. This is to-dos page state, and what we'll do here, we'll actually just take the build. Like all this is like really boilerplate stuff that you already have seen 100 times, so I'm not going to go through it in too much detail. And also we're actually going to copy in some of the code here. So we're going to actually get the app bar in, because there's really no point in implementing that again. So return a safe area. You all know where the safe area has to be there. Think through the iPhone mostly. Let's see what else is going on. So we got the scaffold. We need another. All right. So now we should be fine. So actually now we would be showing at least the title with our little dash and the first. Not much though, but something. The other thing that we need for now is, the body, and that body will have a to-dos view. So let me see where that would go inside the scaffold right here. And we can see that we don't have a to-dos view yet, right? So that's the next thing we're going to implement. All right. So this is the main app, and you can see there's nothing Rid going on here, except that we set it here, but everything else is just normal Flutter. And the cool thing is that the only interaction with actually Rid and the store and all these things is all happening in these cubits, and so our app actually doesn't have to really know that's going on, which I find really nice. So now what we're going to do, we're going to add two views. We're going to add a to-do view, and we're also going to add a to-dos view, right? So those are the two ones we need. All right, so to-do view first. So the to-do. What we're going to do there for now is we're going to do a really, really simple one. We're just going to render some text. We're going to replace that with something better in a moment. So this is a to-do view, right? And so obviously we need to import a bunch of stuff. All right. Now it's rendering an empty container. Well, what does a to-do view actually have to render, right? Let's think about that for a second. It has to basically say, well, is it to-do, did you find the to-do? Or is it a to-do that you couldn't find, right? Those are the two different cases. And if you remember, I just try to show this here. Well, if I can. I think this one should be it. So here, right, like in the case of the to-do wasn't found, maybe we want to render it like that, or maybe we don't want to show it at all, right? So that's what we're basically deciding. So that's why we already, as you know, implemented two kinds of states, right? The missing to-do and the existing to-do. So how do we get those states? Well, we're going to have to use a block builder, right? The block builder from the block package. And the block builder takes a builder. Let's move that. And basically, we have to also tell it what's the type of the qubit that you're actually building for, right? And what's the type of the state. So in this case, it's a to-do state, right? And most likely we have to import this. Yes. So we need to import all of these. Yes. Okay. So now the builder takes a context and a state. And all right, now we're pretty much getting there. So now, okay, let's look at this. These state can be multiple. So one of them is a state can be a missing to-do, right? If it's a missing to-do, well, we cannot render much. We only have the ID. So actually, let me paste. Whoop! But I just can render the ID. I don't actually have access to the real to-do, but I can at least tell you that, hey, to-do is missing, most likely was removed. I don't know, right? Now the other option is that if the state is an existing to-do, right? And so that one we can say, well, we're going to render. For now, we're just going to render the title, right? So we're going to say return text, and we're going to say that this is the state dot to do dot title, right? Okay. And in the other case, what we're going to do is just going to say, well, I'm really, really sorry, but or let's just say if we, well, sorry, I didn't want to do that. In all of the cases, right, if we basically didn't match any of those, then let's just say, I don't know what is this to-do state? I don't know what this is, right? And this is for the future. If we add more states and we forget to update this code here, we get this. So one thing I wanted to point out is, like, how do we know, right, that it's an existing to-do? Right? How does it even happen? And that's what we're going to look at in a moment when we actually implement getting it to do. But for now, we're not worried about that yet. Okay, but you're probably wondering how will we know right? How we will know to create the missing to-do state versus existing to-do state, and we'll get to that in a little bit. Also, if you have any questions, please feel free. I have the chat, as you can see, I have it down here. So ask questions if something is not clear. Okay, so now we basically have the to-do view. Now we need to implement the to-dos view, right? And it's very, very similar. And what I'm actually going to do in this case, since it's so straightforward in a way, I'm just going to actually copy some code here. So let's look at that though in detail. What we're going to do is we are getting again a block builder, but this time we're getting the to-dos Cubit and the to-dos state, right? So then we basically say, okay, we're just reassigning to-dos to not have to say state to-dos everywhere. And then we're using a ListView.builder. And that is in case that we have a lot of to-dos and we don't want to render them all. We actually want the list only to show the to-dos that are currently in view, right? And so what we have to tell it is like how many to-dos there are. And then how do we build a to-do item, right? And now here it gets interesting. First of all, we're getting the to-do that we're currently building, which is given by the index. And then we wrap our to-do view with a block provider. Right? And that's basically where we created Todo Cubit. And that is really important because at this point, right, we're even using the Todo Cubit already here to get the state of the to-do that we want. We could also obviously have just passed in the to-do, but now we can't have any interaction going on with the to-do provider, right? So now let me just make sure that this works. It should actually work. We didn't change any Rust code, right? So we should actually be able to just run this. Let's see if we get lucky. And one thing I wanted to point out in the example that I showed with the counter app, what we were doing is we actually had a... Okay, so we're going to have to fix that. I'm going to finish my thought though. So we had a debug here. We basically had a normal debug derive, right? And if actually Rid encounters that, it will automatically generate debug for us, like methods to basically access the debug output that you would normally print in Rust, and you can then print it in Flutter. So basically, since Rust does a really, really good job at kind of like generating these strings that give us an idea of what our store or whichever struct or enum looks like, we are kind of using that and we are exposing that if you are implementing debug. So now let's actually go back to our error here. Let's see where the problem is. Okay. Okay, so maybe we are just one off. Okay, so it looks like that's what the problem was. Okay, now let's try that again. And see if that works. And the cool thing is you see that we have to pass nothing to the to-dos view because it's all handled by this Todos Cubit, right, that we are providing. So it's very useful. And yeah, the thing is, again, what I like about this whole concept with qubits is that the views have no notion of anywhere of our Rust, right? Okay, so what's happening now? Okay, let's see. I can fix that. To do Dart. We're just here. What is it complaining about? Missing to do is not a type. Yes, it is. Oh, we didn't save that. Okay, let's try that again. So I just noticed that it's using a new build system to build things in parallel. I wonder if that's actually speeds up starting the macOS app. But the cool thing is that once our Rust is basically kind of fleshed out, and we're not changing anything anymore in our Rust app, we don't actually have to restart the every time. We just have to, you can hot reload and hot restart. Okay, so you can see that that actually worked, right? We got all our to-dos showing up, right? So I would call it a success. So this is coming from Flutter, from Rust to Flutter. So this is pretty. It's a pretty good first step, I would say. Now, as I mentioned, we don't know how to get a to-do yet, right? So now, what I want to do next is I want to be able to basically complete a to-do and to then get the updated state of the to-do. And I don't want to have to reload the entire list of to-dos just to get re-render that one to-do, right? So what we need to do is we need to have a way to get a specific to-do out of the mix, and we have to export that, right? And I think we might have done something, or no, we didn't yet. Okay, so, and it's actually pretty simple. So what we're going to have to do, we're going to get a to-do by ID, right? And self, right? We take the store as a argument, and then we're going to say U32, and we're going to look at what that returns in a second. And so what we're going to do, we're going to get the to-dos, right? We're going to get a to-dos, and then we iter, and then we're going to say find the to-do where the ID is the ID you're looking for. Okay. Now the interesting thing is it's complaining now, and what is it returning? Let's just make it add that. Oops, no. Well, it wants to add it here, but we can see that it's adding, that it's returning an option of a reference to a to-do. So let's just put it there. And that's really interesting because that is exactly how this would work, right? Because if we don't have the to-do, well, it's going to return none, right, automatically. The question is, how do we present that to Dart, right? How do we present that something could be something or nothing? Well, we all know that quite recently Dart added nullable types, right? So actually what I'm going to do is I'm going to bind gen again, and we're going to look in a second of what kind of extra method we actually got, and then it's going to make a lot of sense. Mac OS, I'm going to have to rebuild that, and then we're actually going to rerun this, and it should already still work. And while this is starting up, we're going to look at, we're going to actually get into Cubit, and we're going to have a refresh method. So we're going to add that. We're not going to give it a type yet, and we're not going to worry about anything yet. All we're going to do here is we're going to say that we want to get the latest to do from the store. All right, so let's do that. So we have to have a store in this case. Okay, so now we have a store. And what we can say now, store.todo. Okay, so it's not there, and that usually means we have to go to this file and go back because Vim just didn't update it. So now we have a method here, to do by ID, and we can basically say state.id, right? Okay, and let's look at what that actually does. It actually returns a nullable to do. Pretty awesome, right? So basically, if we in our Rust code have a function that we're exporting that returns something that's an option, it will automatically make that into a nullable type in Dart, right? And again, we have the lower level method here that's all protected by the by a read log. So we make sure that we can actually see here, for instance, that read logs are going on. So we are protected by that, and we can actually now say this is the to do now. And so let's look at what we need to do there. So we get a to do, right? Okay. Now the thing is that the to do now, as we said, is nullable. Right? So now what we have to do is we just say that if the to-do is null, then the state is a missing to-do from the state.id that we still have, right? So we don't have a to-do anymore, but we still have the ID. And so actually we don't actually assign the state, we emit this, right? And then otherwise, if the to-do is not null, the cool thing is now, we're going to see in a second, that Dart actually knows now that in this branch, it can't be null. So then we can just emit a existing to-do, and we can now pass it to-do because, as you can see, even though it's still rendered as nullable, but Dart knows that this is fine. Like this to-do now is no longer null. Okay? So that's kind of cool. So we have the refresh method. Let's just put a void here for now. And so now we are able to say, well, if the to-do, for instance, gets completed or anything like that, we can now actually update just the to-do so we can re-render it correctly, right? Now, let's look at how we can actually, trigger that. So what we want is, we want to say, I want to complete, or I want to toggle the completion of the to-do, right? So let's do that. So we're going to say toggle completed. Yeah, completed, and that's it. That's all. Like, it knows what to do we're talking about because it's the to-do qubit of a particular to-do. So then we can say store, please send a message to toggle the to-do, and the ID of the to-do is the ID of our state. Okay, so that's kind of cool. And now let's look at this in a little detail. This thing actually returns a posted reply future, right? And remember, like when we looked at the example here, we showed that every time we actually make a request, right, like a message, it doesn't assume that this message gets handled synchronously. It assumes that it could be handled asynchronously. So every time then, when we then complete handling whatever the message wanted us to do, and we updated the store accordingly, then we post a reply, right? And so that's why this returns a future, so we can await the reply, or we can then, right? So we can say then. Okay, so we can just say, well, then refresh, right? So once the to-do has been updated, right, has been toggled, then refresh. The problem is that this says that this is not assignable because this one actually takes a posted reply, right? So okay, we can change that, no problem. We can just say, and we just ignore it for now. We don't care about the posted reply, right? So now we have this method. But the thing is, we want to be correct, and we want to say that this actually returns the future of void, right? Because this one returns void, and so since we're mapping it kind of over the refresh, we are returning a future of void. Okay, so now we basically implemented the entire code to send a message to Rust, have the to-do updated, and then once we know that it has been completed, we then have the method to get the current state of the to-do, and then emit the state for this qubit, and then the view would get updated, right? So now that means also that we want to kind of show in our view what this would look like. And here I'm going to do some copy paste because there's just too much stuff going on that I don't want to do by hand. But I'm going to go through this piece by piece. So don't worry. So this is for the existing to-do. Okay, so now lots of code flew in. Let's look at this in detail. And we're going to get rid of the errors in a second, right? So first of all, like, we don't need a subtitle, for instance, now. We don't have a subtitle yet. I think this should be fine. Did I do this wrong? Let's do this slower and make sure that I don't screw it up. So this is that. Okay. Okay, so we don't have a subtitle yet. That comes later. And then we don't dismiss anything either. So let's just remove that for now as well. Okay. So dismissible is there because in the final app you'll be able to remove it to do by sliding it out, right? So that's why that's there, and we'll keep it here because we might be able to implement it. Now the only thing we really have to worry about here is that this is basically just a. Let me actually refresh and see if this already works. Let's see. Okay, so now we're rendering the to-dos in a different manner, much more pretty than before. And what's happening here is that when we are tapping, right, on this inkwell, and the inkwell is just there so it has a visual feedback, right? We wanted to get the to-do qubit, and we want to call this function that we just implemented, right? Now, why do we use read? Read is basically just a return provider of, and what it does, and you can see that it doesn't listen. So meaning it's the opposite of like using watch or using a block builder, which basically will get updated every time the qubit emits a new state. Here we're basically just saying, just give me the qubit. Like, I don't care, I don't want to watch anything, just give it to me once, and then I want to execute this method, right? So this might already work. I don't know if you have to hard restart. Oh, it actually already works. Awesome. So do you see, like, we didn't even have to restart the app after we implemented this piece. It just already all worked, which is nice. So you can still iterate pretty fast like you used from Flutter, but you also have all the app logic and security of Rust, and you have all these yeah, you have pretty much everything you like from Rust you have there as well. Okay, so we have that implemented, right? Pretty cool. And you can see the inkwell, like it does this little animation there, and that's why we wrapped it in that. Okay, so that is what I wanted to show there. Now the next thing is the interesting part, which is basically saying that we want to be able to see the to-do expiring, right? So we completed to-do. Right now they're not expiring, right? They stay here, but we want to basically say expire the completed to-dos with this bar, right? And for those who joined late, I'm going to just show this real quick. So when a to-do basically is completed, we have the option of setting auto expiry to true, which has these the ticker thread, which basically auto expires to-dos, and then they kind of slowly but surely the progress bar goes downwards, and then they're just gone, right? So that's what we're going to implement next. In order to do that, we need a few more things on our store, right? Because we need to be able to set the auto expiry. So what we're going to do is implement that first. And again, the not so interesting parts to show actually in a coding way, I'm going to just copy and paste, right? So what we're going to do, we're going to implement settings now. Let's do that. Do that below here maybe. So we're going to have settings, and we're going to implement them here. And so they basically say that, are we auto expiring complete to-dos or not? And then they say, what's the what's basically like the maximum that they can have, right? Like where do they start, basically, right? Like how many milliseconds do they have to expire? And now here we're going to say rid is a model, right? Otherwise we can't use it. Okay, and then we're going to have those settings here. And that's pretty much all there was to it, except that we need to tell it that settings is a struct. And now we also need to initialize the settings here. And again, this is something that is kind of mundane to show in a typing. We're just going to paste that in. So what I'm doing here is that starting out, we don't auto expire to-dos, and then I'm setting it's setting it to 7 seconds to basically how long does it take for a completed to-do to disappear, right? And that's pretty much all there is to it, except now that we need another message. We need to basically set the settings, right? We need to set auto expire to true. So what we're going to do here is we're going to have a message, and it says set auto expire completed, and it's going to take a bool, like either set it to true or set it to false, right? And then basically we're going to have a reply for that. So we set it, right? And here we call it to do. So let's just stay with what I had in the example that I will. If you're watching this on YouTube, the full example will be in the links below. So now we're setting this, and it tells us, look, like there's something you're not covered. Okay, so we didn't cover this here, right? Okay, let's fill the match arms. So so we want to set auto expire completed to-dos. Now this is a little more complex because now we're going to have to say, okay, if you set it to true, we're going to have to start this thread that will do that for you, right? And so that's where things get interesting, though. So let's actually, before we implement this message handler here, we're actually going to say that let's implement that method first, right? And so we're going to implement that directly on the store, and there's nothing we export. It's just going to just do it, right? And set auto. This is a long method name. Expire completed to-dos. And in order to do that, we need a mutable store, and we need to know if did you want to expire or not, right? So those are the things we need to know. Okay, so we got that. Now what we're going to do is first of all, we're going to set the auto expire completed to-dos on the settings to this variable. Right? So now we're pretty much done with that part. Right? We updated the settings, but now what we have to do if we want to actually expire, we have to do much more things. So first of all, I'm using the lowest level here that Rust kind of provides. Like we're using the threads directly. There are obviously libraries around threads that make it a little easier, maybe, or whatever you like, whatever you prefer. Here, just to keep things simple, I'm using the thread directly. So I'm going to have a thread, right? And we're just going to take the standard threads, and we're going to spawn one, right? And don't worry about that syntax. You're just going to move the closure into the thread. I think that's what that actually means. And so that's what we want to do. Okay. Now the first thing in this thread that we want to do, we want to kind of say, oh look, I'm letting you know that I'm actually spawning this. So we actually started auto expiring, right, on this thread. Okay, fine. And actually at the end, when the thread is done, we're going to put that we stopped auto expiring. So we can kind of see when these threads start and when the threads stop. Okay. Now what I have to do next is this. So first of all, I'm going to pull in two methods here, and I'm going to show you why. So these are methods that wrap the store read and the store write, right? And you're asking, why don't we just use this directly? Well, if I hover over this, it says unknown, versus here it knows what this actually is, right? And that's because this method here is generated by Rid, and the Rust analyzer right now doesn't handle code generated with proc macros very well when it comes to IntelliSense and so on. So in order for make our lives a little easier, we just write a little wrapper that we can then use, and then everything is typed correctly. So if I remove this, for instance, right, Rust still knows that this is wrong. It still knows that it's returning that, right? It still knows about that, but the Rust analyzer doesn't tell us that. And that's what's annoying. Like, for instance, if I was to do something here, we get no IntelliSense at all, right? But if I go here and, for instance, use store read, right? And now I click, well, what's going on? Why did that not work? Should have gotten something. Well, normally I would have gotten something there. Might be because there's some other thing going on. Oh, okay, because we haven't imported those yet. Let's import that one and then that one. And so now I think we should get better. So now we get, right, we get basically these things of our store. So now if I do this here, I still don't, right? So that's why I have these wrappers. Okay, long story for the wrappers. And now the next thing we're going to do is, and I'm not going to type this out, I'm just actually going to copy that here, because that's kind of pretty straightforward. So what we're going to do is, while the store, while these settings are still set to basically auto expire, right? If nothing changed in the meantime, then we're going to keep going. And what we're going to do is we are going to sleep, and we don't have the expiry step yet, so let me actually pull that in. So the expiry step is like how many milliseconds per step are we expiring, right? In this case, we did 10. All right, so we got that. And so now all that would do is it would sleep. It wouldn't do anything yet. Now, what I want to point out here is that I did not do this. Right? Let I don't know, store equals this, and then that. And why did I not do that? It's because I'm creating a read log on the store here, and it doesn't get dropped ever. And that's the problem, right? We can't have the store hanging on, because then it will block every other thread from getting at least a write log, right? If you have a read log, no thread can get a write log. And so we can't do it this way. So what I recommend is just to always type it out like this, to make sure that you're not accidentally basically preventing the read log from dropping or the write log, depending on which one it is, right? So now we get to the fun part. So the thread sleeps, and then what we'll do, we actually now need to go through the to-dos that we want to update, right? And since we want to update them, right, we need to acquire a write log on the store, right? And then we get the to-dos, and now we can basically iterate over them mute, because we got a write log on the store. Otherwise, if we had a read log, we couldn't do that, right? So if I put a read here, right, now it's complaining that, well, yeah, you can't. Well, first of all, that's happening, but it now says you can't get on a read lock, you can't get a mutable reference. So if I do a write here, now it's happy about that, right? Okay, so then what we're going to do, we're going to filter the to-dos that are completed, right? And then we're going to say map over them. And I'm going to type the type out here. What we're actually getting is we're getting immutable to-do here, right? And let me actually complete that. I hope that, yeah, I'm getting multiple lines now. And so we get this. And it's complaining that we are not using the result of the map. So let me actually just assign that to something. So it goes away. All right. And so now we can say, well, let's get the next. And actually, I'm going to copy that. I'm just going to explain it because it's like a mouthful, this code. It's fairly simple to understand. So what we're going to do is, and why is it complaining? Okay. What it's doing is it's getting the next value. So we have the current expiry, right? How much did it expire for now? And then we're going to subtract the expiry step. So in this case, 10 milliseconds. And then we're going to look if we reached 0 yet. And if we did, right, what we're going to do is we're just going to return the ID of the to-do and true. And we're going to see why in a second. If it hasn't expired yet, we actually will assign it to that next expiry value that it should have, and we return false. And what's up with this true and this false thing there? Well, what are we returning? And obviously we have to collect at the end. And now I'm going to show you what we're actually returning. So what we're returning is basically a vector, right? We're going to say we're going to call them like the IDs to update, right? And we're going to embed a vector of a to-do, which is a U32. And actually, let me put, okay, there you go, and a bool. Okay, so that's what we get. And so that means that for all these IDs that we have, we give it, we also give it if it expired or not, right? So in this case here, the to-do expired. In this case, it didn't, right? And so then we collect that. And then the next step, we have to actually now perform the step that's for each case. So we have the ID, and then we have the should we remove it or not, right? And then in IDs to update, right? Okay. So now we're going to say, okay, well, if we want to remove the to-do, right, then go ahead do that. So we need to get a write log again, because basically we only want to get write logs especially, but also read logs as for the minimum amount of time. So here we got it and we let it go immediately, right? And now we get a new one here and we say, well, remove the to-do, and we don't have that method yet. So I'm just going to type it out. Remove the to-do of this ID, okay? And we're going to implement that method in a second. And then we also want to read post, and there's another thing we don't have yet. We want to have a reply and completed to-do expired. That's a and now the thing is that, as you can see in this case, we don't give it a request ID. And why is that? Well, there's no message that the users of Flutter sent us that's associated with that happening. It's just the ticker happened to now remove that to do, and therefore there's no message associated with it, right? So that's why we don't pass a request ID. Now, if we don't remove, then we basically just say read post reply, and we're going to say that there's a tick on the to-do, and we're going to give it the ID of the to-do. And as I said, for the reply, we can have a string, and obviously these don't exist yet. And there's another error somehow. As I said, the reply can have a string that can hold data. And in this case, we use that string to communicate which to-do actually expired, right? Passing the ID. And so that's it. And so basically this while loop, as you can see, will run as long as that setting is true, right? So now let's implement the pieces that we're still missing, right? So first of all, from the reply, and I'm just going to copy this. And here it helps probably if you separate these replies and you say these are application events, right? These are coming from, and the other one are like message replies, right? So you kind of have an idea of what each of those are. And you can see each reply has like U64 request ID in it, and the others don't, right? So these are the events, and now actually this one should be happy. And now we just basically need to implement remove to do, right? And so that method is somewhat interesting, but still like not interesting enough to where I will code it out, because I want to kind of get to the meaty part and show you how this actually will work. So where should I put this? Let's just put it right below update to do, or maybe above, because it's actually using it. So what's happening here? Well, the remove to do, right, as we can see here, it's called, should actually now be happy, it's called with the ID, and it's called with the mutable store as a as the owner, right? So the mutable self is over here, right? And so now what we're going to do is we need to get the index of the to-do that we need to remove. So that's what that does. We get the enumerated to-dos, and then we find that to-do whose ID matches the one we're trying to remove, right? And maybe there's a better way, but obviously if you had a hash map, right, that would be easier. But for now we work with vectors. If we find that, then we return that index. If we don't find the to-do, then there's nothing to remove in the first place, so we can just bail out. We can just like return, right? We just leave the function. There's nothing we can remove. However, if you found an index, right, then we remove the to-do with that index, right? And the reason why we do it that way is because we can't, while we're iterating, right, we can't remove the to-do in place. That doesn't work. So we get the index, and then in the next step we remove it, right? And the question is, it says it's never used, but we know we use it here. So that's kind of, because this one is not used yet either. And that's what our problem is. So let's look at that. So because we're missing one last step. Basically, when we have this message, right, to set that the auto expire to true, right, we need to then go and do that. So let's do that. Self.set auto expire complete to-dos, right? And the cool thing is that here we have the setting. So we have the expire variable right here. So we pass it in and done. Except, like at this point, and I might actually show that. You know what? We're gonna leave it like this. And if someone already knows what we're missing, and here we're missing something, we need to tell it what the settings are. I think maybe. Let's see. Is it complaining about something? No. I think it's happy now. But we're actually not really happy. We're missing something here. And some of you, if someone wants to guess in the chat what we're missing, let us know. But what I'm going to do now, I'm going to rebuild the bindings and the Mac. All right. Cool. And what I'm going to do is I'm going to implement the drawer. But first of all, we're going to implement these settings Cubit. And so let's do that. So we're going to add a settings. And why I'm not creating this with a block extension that I had there is because this one, we won't even have a separate state. Okay. So what we're going to do is we're going to have a class things Cubit, and I'm going to show you why we don't have a state in a second. So it's a Cubit, and what we're going to use directly is just our settings. We don't need to wrap that. It's again like we do have settings or we don't have settings, but it's not like, oh, we are in the retrieving state of settings, something like that, right? So it can't find settings because this is like, again, this is because we just generated this, and Vim does not know yet about this, so we actually have to show it. Let me actually go to the plugin and show it, and now it can. No, it should actually be ready to import it. Yeah, now it knows where it is. Okay, cool. So now the next thing is we need a store. with the instance, right? And the store only gets created once, so we don't have to like worry about creating it inside the constructor or anything like that. The store is basically static. It's always there. As long as the app runs, the store is there. It doesn't change where it's located either in memory. It just is there, right? That's why we can always easily find it. So what we're then going to do is we're going to generate the constructor. No, it doesn't allow me to do that. Let's just do it then by hand. Things Cubit. And what we're going to do, we're going to super, and what we're going to pass is we're just going to get the current settings. Well, we're going to get the current settings, and that's our state. And so you're wondering, why don't I need to wrap this in state? Well, the settings already also implements everything that a state needs to implement. It implements equality and hash code. Those are two main things that it needs to implement for us, right? So we don't need to wrap it again because we only need one settings, again, as I said. Now the things what we want to do is we want to implement a method, an async method that basically set auto expire completed, and we're going to take a bool value, and we're going to make this function async, and you're going to see in a second why. So what this function will do, it will send a message to the store. That's why we needed a store. So we have a message now. We can say this, right? So we send that, and we have a val. Now this message returns a future. So what we can do, we can await that, and we don't really care about the reply. We just care that it did reply, right? And then once we got that, we can just say emit store.settings. And you're wondering, how does that work? Like, where did the settings come from? Well, the settings, when we ask for them, they're actually getting like refreshed, right? We're getting them fresh from the store. That's another thing that's important, that everything we do here, we are only ever keeping state in Rust. We don't want to copy state into Flutter and keep it there. We only basically emit state from the qubits, but we don't ever really hold on to them. We just basically get the state from Rust, render it, and forget about it. That's the idea, right? Because we don't want to have two sources of truth. Rust is a source of truth. The store is where all the state is, and that's what we basically always get it from, right? So, okay, so now we get this. Okay, now the next thing is we need to somehow get that to that settings qubit, right? We need to get that into our app, right? And again, this is like a little boilerplate. All we have to do is add this to our, we already have a multi-provider, so we just put it there. And then we just need to import. And now we have the settings qubit, and we can now use it everywhere, okay? And what we're actually going to do is next is to implement that menu where we can set this, right? And what I'm going to do is I'm going to copy a little part of this. Yes, so basically, let me look at this for a second. There are two parts to this. I'm actually going to copy them over, but I'm going to explain this as I'm doing so. So first of all, we need to have a menu, .dart. And that menu has two things. One is we have the auto remove complete widget, and I made it a widget. We need material. Okay, and here we can see that we are getting the settings qubit, right? And so, and I think we need to import Flutter because it's missing. Yeah, we need to, well, we could do provider, but it's better to import Bloc because that's what we use everywhere else. So let's get that from here. So that extension method on the context is provided, is basically implemented inside provider, but we can also get it via Bloc. So let's look at what's going on here. So you have a checkbox, right? And the checkbox is showing what the current state is of the setting, right? And here we're using something that's called select. And there's a huge documentation on this, but basically what it does is we are watching the settings state, but we're really only interested in this part of it. We're only interested in in this parameter, right? We don't care about the rest of the settings. So this is a little optimization here where we don't get to rebuild every time anything in the settings change. We only rebuild this part if this specific value in the settings change, right? It's a cool little feature there. I want to say from Flutter Bloc, but let's double check. So this is defined in the provider actually. Okay, so it's part of provider that gives us it. Okay, now we still don't have, so we have that widget, but we still want to kind of have it inside a menu, right? So let's actually just like create our little stateless widgets here. And what we're going to have a list view. And in that list view, for now we have one tile. And it is going to be the auto remove completed thing. And what we're going to do here is we're going to have a row because we want to have a label. And why are you not happy? Oh, because we need to say children. And wrap that there. I think that should be better, but it's still complain. Let's see. So we got the row. And I think we need one more for the tile. Yeah. So these are the children of this list view, and we basically just show that expire complete is our text, it's just a label, and it's pretty straightforward. I don't think I have to explain that too much. So now let's see where we use that menu in here. So if you go back to our main view here, we have an up bar and we have a body, and we also have a drawer, and the drawer will just be our menu. So. Right, and the menu magically has now access to the settings Cubit because we made it so, because it's included as a multi-block provider, right? So let's start that, and let's see how things work. And ideally, we should be able to already switch these settings off and on. It's probably not going to do anything to our to-dos yet, but we should be able to do it. So let's see. Here we got that, and we should be able to turn that off and on. Okay, so something happened. What happened? And that's what I wanted to show, actually. This is on purpose. So what happened? A timeout expression. So basically, the thread started out expiring. So it got our message. That worked, right? But what happened here? Well, there's an unknown exception, a timeout exception after a certain amount of time, 200 milliseconds. So okay, this is related to this message, right? And it timed out. So what does it mean? Well, it timed out, and we can see actually where we did it, right? We clicked here on the auto remove thing, and then it called the qubit, and then it went to Rust, and then it just, well, this is a warning that you forgot to post a reply. So right, I figured that this might be, and it crashed, and actually we have to like close this now. But I figured that it might be a common thing that people might forget, and that they might forget to post a reply. And so what you can say, and also it might be that maybe you don't get a reply back, right? Maybe you're trying to do something, and your Rust app kind of waits for something and never replies. You need to have a way to handle that, right? So you can set a timeout, and obviously you'll be able to also override what happens if it times out, right? You can say, well, if it takes like 2 minutes, maybe if I'm getting a web page, maybe I should just show something empty and explain that I couldn't get the web page. That's what that does, right? So what we'll do is we will fix it. We basically have to. I'm a little bit. So what's weird is, did I copy that with the rest somehow? No, hold on. Something weird happened, because, oh, I know. Okay, I'm in the wrong. I was in the finished app. That's why I was confused. This is what we're building. So this is where we actually are, and we want to go to the Rust. And what we need to do here is we need to post a reply, hey, we finished. So that's what we forgot, right? We need to say post reply, and we're going to give it the request ID. That's all we need to do. Okay, makes sense. So let me just, in this case, we only need to recompile because the bindings didn't change. And now let's look at now how that gets handled in the settings Cubit, right? So here we now await, and you can see that's how that actually happens. So you can see that this calls into a lower level method, and you can see that you can actually overwrite the timeout, right? And in here there's a bunch of code. I'm going to show in a second. A bunch of code. Let me put that here. There's a bunch of code that actually, if I go here, you're going to see that actually does all this handling. It actually makes sure to show you the best stack it can. Like it basically gets the stack when you send the message, and it then basically tries to help you out to try to find where you forgot to respond. Right now. Now, if you run this, we should be fine, and it's fine, right? We the thread started auto expiring. We got a reply that we set this, and actually now what happened is since we got this reply, the store settings were queried, and that's also why our checkmark is now checked, right? So this all works now as expected, right? And because the thing is, like, if I wouldn't have the warning in there with red, right? You might wonder, why is this not updating? What's happening? Well, because you never got the reply, right? And so you want to make sure that basically I wanted to make sure that you don't accidentally forget that and have to debug forever to find that out, right? Okay, so but now we still don't actually auto expire, right? If you actually said this, nothing is really happening yet, but it is actually happening. Get off it. Let's look at the Rust code. Like how far did we actually get with the Rust code? Right. So the Rust code actually does do all these things. Right. So why are we not like, oh, look at that. What happened? Well, somehow we tried to get this to do, right? But it was gone. And you see that how that worked, right? Like we didn't crash. Like this was a to-do that wasn't even there anymore. And we tried to get it, but correctly, basically, since we're sending an option, right? And which then is converted to a nullable value, it correctly basically gave us this kind of message instead of crashing. And that's what I'm saying when I say it's memory safe, but it gives you a really nice API, and you don't have to worry about the memory safety. It's done for you, right? Okay, so it apparently works to expire the to-do, but we didn't get that update. We didn't get the memo. Well, one thing you want to do is we want to actually, in this to-do here, right? We were not showing this expiry thing yet. That's the first thing. That's probably the more fun thing to do to show that, right? And so there are a few things that we need to do. One is we need to implement that expiry. And again, this is something that is fairly verbose, but not really essential to what we're doing. So I'm just going to copy that also in, expiry.dart, and I'm going to just talk through it real quick. It basically just expires, well, actually it doesn't do anything, it just renders, right? And depending on how far we are expired, right, here, the remaining millis compared to the the total, it renders like a progress bar but backwards, right? And then to add a little extra twist, depending on how much it expired, it actually changes the color, right? Green to orange to red. When it's almost gone, it's going red. Okay, so that was the easy part. And now obviously we would have to include that in the to-do. So what we're going to do is inside the to-do, remember that subtitle that we deleted? Well, I'm going to put it back. So the subtitle is what's actually going to show this. So let me make sure I put that in the right place, right below the title. which I don't see. Oh, here it is. Okay, so so what's going on here? First of all, we need to now listen to the two things, right? We need to listen to the block builder, and then since this settings is actually coming from the generated code, we needed to import that as well. And then we have the expiry widget, which comes from the one we just implemented. So now what's going on here? Actually pretty simple, right? We got the block builder, which has these settings. So now we have access to the settings, and every time something changes in the settings, we get updated. And now what we're saying here is if we are auto expiring and this particular to-do is completed, then actually show the expiry widget, right? Show basically the progress bar on the bottom. Otherwise, just show empty, like don't show anything here, right? And so this might already work. So let's see what's happening here. And it didn't. Maybe I didn't save everything. Okay. Okay, now we can see actually that this one is already showing an expiry bar. But it doesn't get any updates, right? It doesn't. So now if I do this, if I check this now, this one also, but it doesn't get any updates. Now I bet you if I check this, it's also going to do that, right? And I knew that was going to happen because it actually already got removed, right? But let's work on getting the expiry bar working first. So right now it's not moving the expiry bar even, right? And we're going to fix the updating the list of the to-dos later, right? So let's get the expiry bar done. So what we need to do for that is in the to-do Cubit, we need to actually listen to those events, right? So right now we are not aware at all if our to-do is like expiring, if anything is changing, no one really cares, right? So just to rehash, inside the Rust thing, inside our Rust code, we are actually emitting a tick event here. But no one cares about that tick event. It's not associated with any message, right? So no one really cares. No one really cares about this one either, about the completed to-do expired either. And that's what we need to basically fix. So since it's not associated with any message, we do this a little differently. What we're basically going to do is we're going to implement, let's just do a subscribe method. So we're going to subscribe to something in a second. So we're going to take a reply channel. Reply channel is a thing that's also provided to us by Rid, and it has a stream. And we can basically say, listen to the stream where, and we are interested in ticks, right? So we can say, if the type is reply.tick, right? And now you can see that also these this enum here is a Dart enum, but it matches exactly the enum that we defined in our reply in Rust, except it doesn't have any data because in Dart you don't have that, right? But we can still check the type. And then also the other thing is we need to figure out if this is for, if the tick is actually for this to-do, right? And so we're going to pass the to-do in here, and we're going to implement that in a second, but let me just put it there to not have any errors going on. So this will return a Boolean, right? And it will basically get the posted reply, right? And the reply will have information about the to-do. So we're going to check that in a second. So I'm sorry, like X is actually not the to-do, X is the reply, obviously, right? And so for those ones, we want to listen, and if that happens, the same as when a message completed, we just want to refresh. That's all we want to do. And that's it. That's all we have to do. Now, obviously, since it's called subscribe, this returns a subscription, right? So I want to actually, well, we're going to do that because this type is a little bit big. So we're going to do it like this. And we're going to say final, the tick sub, right, is this. But since we're not assigning it in the constructor right away, we're going to do a late final. And then we assign that sub to that. And now obviously we want to make sure we clean that up, right? So I wish there would be some way to help me. But basically the close method is something that's provided by the, and so we have to do super close. I'm just going to show you right away. So this one is provided by the Bloc package, right? It's a close method that we can call. And obviously we have to have the same return type. And so we call super close, but first we are canceling our sub, right? And now this is like not at all like related much to Rid or anything like that. That's just how this works with providers, or in this case with the Bloc. Now, why is it complaining? Oh, we have to return this. Okay. Okay, so that was a mouthful. We still need to. Well, why is it complaining here? Oh, because we actually don't have to do this anymore. All right. Now it's complaining that this method is not implemented correctly yet. Okay, so now the question is, how do we make sure that this is for this tick, for this to do, right? Well, first of all, we have to say that. So let's look at the reply real quick. Reply has a type which you already checked for, and it has a request ID which we don't care because it's not. There's no message there, and it's actually therefore nullable. In this case, it will actually be null because it's not related to any message, but it has a data property, right? And remember, in the Dart. We basically here we call this with an id.toString, which becomes the data over here, right? So we have basically access to that. But first of all, we have to make sure that this one is not null, right? And I'm going to copy this long message that I put here from the other code. But basically, we're saying that reply tick should include data, right? But the thing is, like on the Dart side, we can't know that, right? Because all the posted replies have the same class, so some of them they have data and some of them don't. So we just need to make sure here that it does. And then the other thing is, I'm going to copy and paste that here. It's basically that we try to parse the data, right? I mean now we know it's not null, so we can enforce that. And then we also enforce that we got something, because try parse basically returns null if it can't parse it correctly. And then if it is, then we say, well, it is for our to do if the ID that was included for that tick is the same as our to do, basically our state, right? And so that's that. And now all that's left to do is actually call that subscribe method. And I'm not sure if this will actually work immediately because we changed this Cubit, which is kind of like really high up in the widget tree. So let's see. So we refreshed. It might not work. So let's see. Okay, we got something. It keeps expiring. And now it's gone. Okay, so that was interesting. So there are numerous problems. One is it doesn't update by itself, right? So let's see. What I'm going to do is I'm going to hot reload, see if something fixes. Okay, so now these are gone. These weird to-dos. Okay, but now we can see that it actually worked. So it was because we didn't fully refresh. Now if I remove that, the thing is it doesn't reset. So every time I should actually toggle to do it, we should actually reset the time, and we're going to fix it in a second. But we can see that we actually got now the to-do qubit listening to basically expiry events of itself. And again, we can see that from here, right? It kept getting updates about just that one to do. Like we did never go and get all to do. Well, there's one left, but even if there wasn't, actually I'm going to kill this. I'm going to restart in a second. But even if there wasn't, it would only get refresh its own to do, and not like the entire list, right? And we can see that here that because when the tick is for us, we actually refresh, and that's basically when we call this line, it actually calls this one over here, right? Now let's fix this one thing that's bugging me a little bit, is that when we actually toggle it to do, we actually need to also reset. Where is this? We also need to reset the expiry, right? So let's actually look at how we did that over here in the completed version. And what we did there is we implemented a method because we're going to have to do it in multiple places. So let's just actually do that. So in the to-do, where's our to? Here we go. We are going to import something like we can set completed, and not only does it set completed, but it also resets the expiry, right? So then what we can do in our message handler, we can say set completed, and it's the opposite of what it is now. Okay, so now I'm going to so anytime you don't change anything about exported methods or fields, you can actually just refresh. You can actually just rebuild. Every time that you actually change exports or you add fields or whatever, you then have to also regenerate the methods that is generated for the Dart side, right? That's what the bindgen does. Okay, so now we should be fine. And if I run Flutter now, we should actually have the correct behavior. So let's look at that for a second. And what I'm going to try to do is I allocated 2.5 hours roughly for this. So once we get this working, I'm take a vote in the chat what we should do next, or maybe we'll just decide on one. So okay, so we don't have expiry completed yet turned on, right? Okay, fine. So I'm gonna make this a little bigger, and then what I'm gonna uncheck those for now. I'm gonna turn this on, and now if I do expire, you can see that they are actually expiring. Okay, perfect. And now if I set it back, they start expiring from the beginning. So that's the part that I wanted to fix. So and again, all this is handled in Rust, right? There's no, I mean, if you look at the code on the Flutter side, right? I mean, first of all, the views don't do anything, obviously, but even inside the cubits, right, there's really nothing going on. Like we're just listening to these events, and then we just refresh. Like there's no logic. We don't make any decisions. We just say, oh, if I got a tick. Well, here we check if this is for us. But if I got a tick, let me just update. I don't know what happened, but I got a tick. And I'm just going to update, and whatever Rust tells me what changed is what I'm going to then emit, right? So that's kind of the beauty of it. Like all the logic is in Rust, and as we saw, it was really easy to add another thread to it and have stuff handled on a different thread. So this all works really nicely. All right. So now the last thing that's missing is we need to also remove a to-do. Like once it expired, right, we don't actually remove it from the list yet. And then what we get into these situations where a to-do is actually no longer there and we can't even show anything about it. So where do we implement that? Well, obviously, if we are kind of modifying the list of the to-dos, that's not the job of the to-do qubit, but that's the job of the to-dos qubit, right? So there's nothing in here yet. So it's actually fairly simple. So and I'm going to just move that over a little bit. So first of all, what we need obviously is subscription, right? And we also need a store. And so this is our Steam subscription. We need to import this. And so we're going to have another subscribe method. And now this is going to be interesting. So we're going to have subscribe because these ones are actually interested in a lot of things. So we're going to get the, we're going to assign this, remove to do sub equals, and we're going to say replyChannel stream. So where, and now this is where we want to add more and more things later on. But right now, the only type that we're interested in, right, is reply completed to do expired. That's what we're interested in, right? Later on, once we can actually remove to-dos, like with the dismissal, which you probably add next, then we also need to listen to that. Okay, now where that is true, and we don't care which to-do that is, right? So we just listen to that, and then we want to refresh. So we don't have that. We don't have a refresh yet, right? So I'm going to actually implement that pretty much right below here. So what we need is we need a refresh. And in this case, we want to refresh a list. And we have a reply. We don't really care what that is. Now, why do I have an async here? Well, because this. When we know that something changed about our to-dos, we need to get the state from the store. So we're going to get the filter to the filter might have changed, all kinds of things might have changed, right? In the future, the filter will change. So, okay, so we got the filter to-dos, and I forgot the equals. So we got the to-dos, and as I mentioned before, this is now already a list of Dart to-dos, right? We already bypassed all the boilerplate and kind of where we have to be careful dealing with pointers that come from Rust. That's all hidden from you, and it's guaranteed to work, right? And now we basically say, well, just emit a new to-do state with those to-dos, right? Like there's no decision to make here because we always just have a list of to-dos. We don't care. Now the other thing that I'm going to do, we're going to add, well, we could debug the store here, but we're not going to do that now. But you're going to see if you follow the example, which by the way, I'm going to put here, the code of this example is here. If you look there, we actually are debugging the store there just to see like that what happened, right? Okay, now we need to hook up the subscription, right, in the constructor. Subscribe. And I don't think we need this anymore. Okay, cool, we got that. And then here when you just say refresh list. Okay, so that should work. And another interesting thing is I want to see if this actually already works. If I just hot reload versus restart, right? So let's see. If I do this, right, this should kind of already do something. If it gets hooked up. So let's see. We're going to let one expire. Let's see what happens. Okay. It got removed, like the to-do tried to get it, so the list didn't tell it, like the Todos Cubit did not actually update it didn't update this list view. So that's not what we wanted. So let's do a hot restart actually. And let's expire one more, and it should work. Otherwise we'll have to restart the app. But as we saw before with cubits, if we do a hot restart, it actually works. And now it worked, right? Now it removed the to-do from the list. And that's because I was listening to these events coming through, right? So I hope that makes sense. Now what we can do is since this is like a dismissible, right? Like that, right? We can also implement a way to remove the to-do by hand, right? So that's basically what I want to do next. And as I mentioned, I won't go too far with this application. The main thing here that I wanted to show in this video was how basically multi-threading works and how you don't have to deal with all this under the hood. And what I'm actually going to do before I move on to manually removing a to-do, I will actually go and explain a little more what's happening under the hood here. So for instance, here we have filter to-dos, right? How does this work? So we go here and we can see we're getting back a list of to-dos, right? But actually what's happening is there's a read method, and the read method does nothing else but lock the store. We already showed that, right? And then basically locks the store, and it runs this here to completion. Like this is basically what it prints to help us out. Like we can see this here, right? It gives us a little bit of feedback. Why am I locking the store? What's going on? What am I doing? I'm getting filter to-dos. Okay. And then it basically runs this entire method here to completion. So what does it mean? Well, it first goes here and gets filter to-dos. And you can see that now we are kind of on the lower level API that you can also access, by the way. And it basically now goes and gets the filter to-dos from the store, right? So now it got a pointer of a vec. So very, very dangerous. You don't want to necessarily deal with it yourself. But then what it does, it takes that, and if it wasn't null, right? Sorry, I'm in the wrong place. Filter to-dos. If it basically it takes that and calls toDart on it. And what does toDart do? It basically iters over that list, over that vec that came from Rust. Now, remember, at that point, the store is still locked. So we know the pointer we got is valid, right? And we also know that whatever the length of the vector was is still correct. So we can iter over this and map every to-do item, which actually is a pointer, right? We can map that to a dot object. And that's what that does, basically. It takes it creates an instance of the to-do, and now you can see that it's operating on this pointer. So when we call this .title, right, it actually goes and it gets the title from Rust, converts it to a dot string, frees the original Rust string that was used to transmit that information, and then comes back. And all this stuff is handled for you under the hood. So it does it for all the to-dos, and then it comes back. And by the time now that we unlock the store, right, we already have the complete dot object. We are not going to access the store anymore. We are safe, right? So that's basically the API that I implemented on top of the raw API. Now you can still get the raw API. You can do store.raw, and you can also get to-dos from here, right? But now if I assign this to a variable, and I show the type here, now we're dealing with pointers. Now we're dealing with raw. So I called everything that's so to speak dangerous, I called this raw, like Rid calls this raw. So anytime you have raw somewhere in your code, you probably should be careful. The reason why it's there is maybe you have like 1 million to-dos, right? And obviously in that case, you don't want to convert them all to dot objects. That would be really expensive. You may not even want to get them all. So in that case, you can use the raw API to piece by piece go through the to-dos, get as many as you want, and then maybe just only pull the ID out if you're not even interested in the title. But at that case, like, you have to basically lock the store. Now you can easily do that. There's a run locked function. Well, on the raw API, there's a run locked function there that you can say, I want to do all this stuff, and I'm going to give you a function. And while I'm inside here, inside this block, right, this basically gives you a store object that you can use, right? In this case, it's the raw store object. So you can do store.get to-dos, right? You can do all these things, and while you're basically in this function, the store is locked, is read locked, so you're safe, right? But I didn't want you to have to worry about this by hand. I wanted to basically make this really, really easy to use. Okay, if there are any questions, let me know in the chat. Otherwise, we're going to implement one more thing, which is to basically just remove a to-do by hand, right? And for adding to-do and all these things, you can basically go to the finish one where I accidentally ended up at some point, right? You can see that here, I'm just going to show actually the messages and the replies. We have way more messages that we can send, way more things that we can do, right? We can set the filter, but in the essence of time, I'm not going to go through all this. But I think the main idea at this point is clear, right? So just for demonstration, I'm going to add one more feature, which is remove a to-do. So let's just do that. First of all, since this requires Rust code, we probably going to have to restart our app, and therefore we just kill it. And we're going to go now and add this function. So we need another message, right? And I'm going to look over here to make sure I don't do this in a way that's not ideal. But basically what we need to do is, so we toggle the to-do, right? So toggle the to-do. So remove to-do is actually really similar. So of toggling it, we're removing it. So we still need the to-do ID. And then also we need a reply that we removed it. And we give it a request ID. And in this case, we probably don't need to have, well, actually, you know, someone may be interested in knowing which to-do got removed. So we just exclude it anyways. Now we get the warning of Rust that tells us, hey, you're not handling that case yet, right? This is actually very nice because we can just say every time we add something, we know that we'll be alerted if we didn't handle that case yet, the message. Okay, so let's get out of this. Okay, now we get the ID, right? So let's actually see how that's implemented. And what we're actually going to do is we're not going to implement that right here. It's actually kind of a nice practice to implement that here. And the funny thing is we already implemented it. Why did we implement it? Well, the thing is that the thread ticker, right, already uses that function. Okay, so we're pretty much done. Right, so we got that. And we are going to just say that self.remove to-do ID. Done. Except one thing we can't forget is we need to post back that we're done, right? And obviously here it seems like weird, right? Because this is all happening this is all happening synchronously, right? So why not just say, well, on the Flutter side, call remove to do, and then on the next line continue, right? So as in, let me show you this. No, that's not what I wanted. Let's try to find something where I can show this. As in here, where we are saying that toggle to do, right? So why not just say toggle to do, right? And then refresh on the next line. No, then. The thing is that we're using Rust, right? So we want to actually make use of the fact that Rust can just easily create threads and offload work onto other threads so that our app stays responsive and like we can still move around in it while, for instance, a longer running request is going on. We don't want to block the main thread and wait for something to complete. If it's that easy in Rust, we just put it on another thread. And so therefore we need to make the assumption that everything could be asynchronous. We can never make the assumption that something completes synchronously. And that's why we just have this request reply pattern, right? So, but let's go back to what we were actually trying to do. Now in the Todos Cubit, right? So now the remove to do is actually initiated, right? We're removing something from the list. It's not really about the to do, right? It's more about the list. So but I mean, we could go either way. But in this case, we're going to actually implement it inside the Todos Cubit, right? And you want to see how easy that is. At this point, once you have this set up, you're going to see it's easy to add more messages. So we're going to say remove to do. We could do this here. Okay. I kind of changed my mind because in the example, I actually did it differently. And I want to kind of stick to the example. So we're going to go actually to the to-do cubit. And we're just going to say we remove the to-do. And the thing is, we don't actually need the ID, do we? Right? Because we have the ID here. So I'm going to actually deviate a little bit from the example that I have online. So we still don't have that message. So actually, what we need to do, we're just going to take this one. We're going to jump here. We're going to jump back. And now we should, oh, well, I need to run bindgen. Because we added messages, right? And we added replies. So therefore, we need to run bindgen. And we actually also want to rebuild the actual Rust app. Okay. So so now still don't have it, right? But now if I go back and forth, it should refresh it. Come on, you can do it. There you go. Now we have that, right? Now we have remove to do, and we're just going to say state.id, right? Because we know our state, we know our ID. That's it. Almost. You just have to say when you're done, refresh. Now, if you forgot that, that's not going to really work because then we never update our state, right? After the message completes being handled. Okay, so that should be all we need here. Right? And now actually I'm going to start the app while we're working on the rest. So obviously someone needs to call that. So where are we calling this? We're calling this inside the existing to-do, right? Now, we have a dismissible here, right? So the dismissible allows us to, and I'm going to double check the way that I had it here. The dismissible allows us to say, well, if something is about to be dismissed, right? So here, this is an interesting actually aspect, and this one I'm going to take a little time here to explain this. So there are two dismissed things. One is just on dismissed or something like that. On dismissed. Well, the thing is that here on dismissed, it's just a void function, and so the to-do got dismissed, and it's telling us and it's expecting us actually to now synchronously remove something from the list. Right, but as we just said, we don't do anything synchronously, right? when we communicate to Rust. So that won't work, right? So basically what's going to happen is we're going to basically remove the to-do, but we're still waiting for the reply, and at the same point it's already going to re-render, and it's going to complain that something that was dismissed is still in the list, right? So what we actually need to do, there's another function, and it's called confirm dismiss. Now this function takes a future, and that's exactly what we need. So we can say, well, someone wants to dismiss this to do, and what we're going to do, I don't think the function is necessarily made for that. It's supposed to for you to confirm, but in a way you can say, well, we're going to try to remove it from the Rust store, and assuming that everything goes well, we return true. Now, if there was some error, we could handle that, right? But for now, we don't have any errors there, so we just always return. So what we're going to do, this function takes, I think, the direction which we don't need, and then we're going to say that we want to get access to the to-do qubit, right? And on that one, we now want to remove the to-do. And now this one returns a void future, right? So what we need to say then is like we want to convert that into a Boolean. Now obviously we could have changed the remove to-do function as well to return a Boolean, but for now we just do it this way. Okay, so that's what that does. Now theoretically, if I refresh, this should already work. But I think every time we change a qubit, we might have to actually do a hard restart. Here the thing is, what you notice something. I did a hard restart, right? But the state is still there. And that's it. One difference from working with Rid and Rust versus just Flutter. In Flutter, when you do a hard restart, it forgets everything, right? But in this case, the state is in Rust. So it actually doesn't forget what the store had. It actually still knows what's in the store. And so basically we can even do a hard restart and we don't lose our state, which is kind of nice. Obviously, if people have a problem with that and they actually want to reset the state, we can implement something along those lines, or you could just basically have a message that says reset the store to some older state, right? So now what I'm going to do is I'm going to remove this one and I'm going to see if that worked. And so this is interesting. We got a 2 missing and was most likely removed. So nothing really broke, at least nothing crashed or anything, but somehow this one didn't properly work. So let's see why not. Well, this Todo Cubit, how is it supposed to know that the to-do got removed, right? Like the Todo Cubit did it, and the Todo Cubit has no notion of it. And that's kind of where Riverpod, right, allows you to connect providers together and watch one after the other, or watch one from the other. Well, we don't really need that, right? Because as I mentioned, we have the stream already. So what we can just do here is, we're not only interested in if a completed to-do expired, we are also interested in if it to-do got removed, right? So if someone removed the to-do, that's what's interesting to us as well. And then we also need to refresh the list, right? So if you think about it, these are just 2 different ways of how to-do could have gotten removed, right? So, and I'm kind of saying if a hard reload will just work now. So let me just remove this one. And it did not, so we do a hard restart actually. And we're running out of to-do, so okay, now it actually did get that message. Well, actually probably just refreshed. But let's just do this one here now. And let's remove it. And it still did not work. Let's think about why not. Think about why not. I'm sure we are posting back because otherwise we would have gotten an error. And that's kind of like why this is nice, the whole timeout thing. We did post back, right? We may have to restart the app. I'm running out of to-dos, as you can see. Let me just... It might be that the qubits didn't properly reinitialize. Okay, so somehow this is not working. So what I'm actually going to do is I'm going to restart the entire app. But let me actually make sure that I have it compiled. And because theoretically this should work. And you kind of see that we call it remove to-do sub, right? Because it's all kind of ways that a to-do could have gotten removed. Do I need to? Oh, yes. Did I type or end? Thank you very much. These are the kind of errors that on a stream you spend way too long to catch. So thank you very much, AwesomX, and thanks for joining. Very, very good catch. Very good catch. All right, let's see if this already works now with a hard refresh. Okay, so it did not. So we need a hard restart, actually, most likely. So let's remove this one, and it worked. So yeah, it was the OR that we needed. Okay, so at this point, as I mentioned, I'm going to put this again. So this is the project that we're doing is basically this one with the added feature of expiring to-dos. And let's just look at it one more time while we're talking. Right, beautiful. And it's a kind of with extra features, and the code for this one with Cubit is here. Make sure to go there. And that's pretty much all. So Rid itself lives here. So you can go there and read about the docs and everything. Now, as I mentioned, this code that I just posted has a lot more features that we added there. We can filter. Here we didn't have a filter at all. But basically in this, as I said, in this video, we just wanted to focus on using Cubit and also using kind of having multi-thread applications work and showing that the state actually is safe, right? That we don't run into any race conditions or anything like that, right? So I hope everyone enjoyed that. Make sure to, if you're watching this on YouTube, make sure to like the video. That's really actually important for me to see which videos are kind of perceived better, maybe which videos help better understand these things. If you're so inclined and you want to help me actually open source Rid, feel free to sponsor me on GitHub. The link will be below in that video. So like they always do, like below here, there's going to be a link. And except for that, thank you very much for watching. I hope this was useful, and I'll see you next time. For people interested in what I'm working on next for Rid, I'm actually adding Wasm support. Right now, Rid can only be used in Android, macOS, Linux, iPhone, and I said only, and now I'm like listing all these off. And there's no browser support yet. But I'm working actively on supporting Wasm as well. And then it's going to be even nicer to have these examples in the website actually be interactive. So, and once I have that finished, I will stream about it and I will put videos on YouTube. So make sure to follow me here on Twitter, Twitch, and make sure to subscribe to me on YouTube. And thank you very much for watching.